Welcome to the unit on graphs and transformations, straight line, trigonometric and quadratic functions. The objectives for this session are to explore transformations of straight lines and trigonometric functions f of x. The questions we will be considering are: how will a function be transformed when we add a positive constant to x, when we take a positive constant from x, or multiply x by -1, or add a positive constant to f of x, or take a positive constant from f of x, or multiply f of x by -1. The effect of transformations on trigonometric functions is similar to that of polynomial functions. So consider a function f of x. Some of the transformations we can perform on this function are the following: add a positive constant to x, take a positive constant from x, or multiply x by -1. When we add a positive constant to x, f of x shifts left. When we take a positive constant from x, f of x shifts right. And when we multiply x by -1, f of x reflects in the y-axis. When we add a positive constant to f of x shifts up. When we take a positive constant from f of x shifts down. And when we multiply f of x by -1, f of x reflects in the x-axis. Let's have a look at this pictorially. Adding a positive constant to x, f of x shifts left. Taking a positive constant from x, f of x shifts right. And multiplying x by -1, f of x is reflected in the y-axis. And similarly, adding a positive constant to f of x shifts up. Taking a positive constant from f of x shifts down. And finally, multiplying f of x by -1, f of x reflects in the x-axis. So here's a summary of the transformations of functions which we will be considering in this session. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at example 1a. The point P equals 3, -1. You are required to give the coordinates of the new position of P when the graph is transformed to the graph of y equals f of x plus 2. So what are we doing? We are actually adding a positive constant to f of x. This graph will shift up by 2. So add 2 to the y coordinate of P. So the new value of P will be 3, -1 plus 2. So the new coordinate is 3, 1. Let's now solve example 1b. P equals 3 -1. You are required to give the coordinates of the new position of P when the graph is transformed to the graph of y equals f of x minus 2. In this case, we are taking a positive constant from x, therefore the graph shifts right. So take 2 from x coordinate of P. P new is therefore 3 minus 2, -1. and so the new value of the p coordinate is 1, minus 1. Now let's have a go at example 1c. You are required to give the coordinates of the new position of p when the graph is transformed to the graph of y equals minus f of x. We are therefore multiplying f of x by minus 1, and this is a reflection in the x-axis. So we multiply the y-coordinate of p by minus 1 to give that the new coordinate of p is 3, minus 1 times minus 1. So the new coordinate is 3, 1. Now let's have a go at example 1d. Again, p equals 3, minus 1. We are required to give the coordinates of the new position of p when the graph is transformed to the graph of y equals f of minus x. So since we're multiplying x by minus 1, the function reflects in the y-axis. So multiply the x-coordinate of p by minus 1 to give that the new coordinate of p is equal to minus 1 times 3, minus 1. So the new coordinate of p is minus 3, minus 1. We will now have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a look at example 2a. We have a graph of y equals sine x, and we are required to sketch the graph of y equals sine x minus 90 degrees. So we are actually taking a positive constant from x, and therefore the graph is going to shift right. So the graph of y equals sine x minus 90 degrees looks something like the one that you can see on your screen now. The graph has shifted to the right by 90 degrees. Now let's have a go at example 2b. Again, we have the graph of y equals sine x, and we are required to sketch the graph of y equals 0.5 plus sine x. In this case, we are adding a positive constant to f of x. Therefore, the graph is going to shift up. Therefore, the graph of y equals 0.5 plus sine x has shifted up by 0.5. And now for example 2c. We have the graph of y equals sine x, and we are required to sketch the graph of y equals 1 minus sine x. So there are two things going on here. We're first multiplying the function by minus 1, which reflects in the x-axis, and then we add a positive constant 1 to f of x, and this will shift the graph upwards. So in this graph, we've multiplied by minus 1, so that's reflected in the x-axis. And then when we add the positive constant 1 to the function, y equals minus sine x, it will shift the graph upwards. So here the graph has been reflected in the x-axis. So here's y equals sine x and y equals minus sine x. Next, when we add 1, the graph of y equals minus sine x shifts upwards by 1. So looks something like the one that you can see at the bottom of your screen. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at example 3a. we are required to describe the transformation that maps the curve with equation y equals cos x onto the curve with equation y equals minus cos x. Now clearly we've multiplied f of x by minus 1. This is a reflection in the x-axis. Therefore the function y equals cos x is reflected in the x-axis to give the equation y equals minus cos x. Now let's solve example 3b. We are required to describe the transformation that maps the curve with equation y equals cos x onto the curve with equation y equals 2 plus cos x. Clearly here we've added a positive constant to f of x, so the graph will shift upwards. And so the function y equals 2 plus cos x has shifted up by 2. Now for example 3c, we are required to describe the transformation that maps the curve with equation y equals cos x onto the curve with equation y equals cos x minus 45 degrees. Here we've taken a positive constant from x, so therefore the graph is going to shift right. The function y equals cos x minus 45 degrees is shifted right by 45 degrees. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's try solving this. The graph of y equals f of x is shown on your screen, and the graph A is a translation of the graph y equals f of x. Write down the equation of graph A. Now, as you can see, the graph has shifted left. So we've added a positive constant to x to make the graph shift left. And therefore, y equals f of x plus 2. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. In this example, we have a sketch of y equals f of x, and we are required to sketch the graph of y equals f of x minus 2. What we've done is taken a positive constant from x. And therefore, since we've taken a positive constant from x, the graph is going to shift right by 2. And therefore our new graph looks something like the one you can see on your screen. This brings us to the end of this session. If you have understood the content of this session, you should be able to recognize how a function is transformed when we add a positive constant to x, take a positive constant from x, multiply x by minus 1, add a positive constant to f of x, take a positive constant from f of x, or multiply f of x by minus 1. If you would like to understand this topic in greater depth, do attempt the exercises in your textbook related to this topic. Thank you very much for listening.